All right. Well, we can go ahead and get started. Hello, everyone, and welcome to this Kendall Hunt webinar, helping students understand operations and supply chain management through simulations. In this presentation, you will be introduced to how Excel-based simulations can enhance your students' learning of operations management course materials. Before we begin, I'll just go over some housekeeping points here. So this webinar will be recorded and you'll be receiving access in the coming days, as well as our presenters' contact information. And feel free to ask questions throughout the webinar using the chat and Q&A functions, and our presenters will answer all questions at the end here. So now to introduce our speakers, Ganesh Vaidyanathan and Rene Ordonez, and I will hand it over to them.
All right. Good morning from Ashland, Oregon, Southern Oregon University. My name is Rene Ordonez, and I am a professor here at the School of Business at SOU. Today we're going to highlight or showcase the great features of the textbook that the operations and supply chain management. So what you are seeing on your screen right now is the workbook that it's an Excel-based workbook. It is an interactive workbook. This is a supplement to the textbook. This particular workbook has been in development for several years now, but when Ganesh approached me to partner with him in the textbook, I had a chance to tailor many of the models that are part of this workbook to complement the OSCM textbook. So this is an interactive, again, as I said, Excel-based workbook that contains many of the decision-making models in the textbook, organized by chapter and by topic. So what you're seeing is the main menu of the workbook, which contains hyperlinks to various worksheets at the bottom here, the tabs for the various worksheets. So to facilitate moving from the table of contents or the menu to the worksheets, the models are hyperlinked by chapter. So for instance, if you are discussing forecasting tools out of chapter 2, you can click on the hyperlink to forecasting model menu, and we'll bring up the sub menu for the forecasting time series models. So let's take a look at the main features of these interactive models. For example, if you have a problem, you're working on a problem in a textbook, you can work it by hand and also allow the students to simulate the problem using the model. So let's say that in one of the problems that is assigned to the student involves time series forecasting. And then the problem asks for the use of the moving average method in forecasting. So we'll click on that link. And here's the moving average model. One common characteristic or feature of the models here is that the yellow cells, these are all input cells. So just have to input the data, and by inputting the time series data into the worksheet. So let's just delete certain parts of this data set. For example, you're doing a sales time series analysis. Note how the chart, the graph that is connected or linked to the data. And then you can also see that in terms of number of periods to include in the moving average, the student can play with the number of periods from 1 to, and this particular model can accommodate up to 6 periods. So let's just say that you want to do a 2-period moving average and change that, and you will note that the graph also changed. Since we have only 6 time periods here, we can say what is the forecast for time period 7? And the graph will show the forecast for time period 7 as 300 units. All the graphs that are contained in this workbook are editable. So if you have a student, or if you want to change the scaling of the horizontal axis, you can easily do that by changing the formatting the axis. So, this is a good way for students to also learn and practice manipulating graphs, editing graphs. So we have all of these models are found in the textbook. We can look at, for example, weighted moving average. So in all these models in forecasting, we've also are computing measurement of accuracy, such as the MAD, the MSE, the root mean square error, and standard error of the estimate. So if a student is doing a what-if analysis, comparing various forecasting models given a data set, they can take note of these accuracy measures and make the comparison. So that's the forecasting chapter. For project management, let's take a look at what an example of a project management worksheet looks like. Once again, the yellow cells are input cells, and the blue cells are computed by the model automatically. Okay, let's take a look at the learning curve models. So here's an example where the learning percent is computed based on certain observations. So once again, if the data set contains only 6 observations, we can delete those, and you'll see that the learning curve also changes along with the data. So the improvement in terms of doubling of repetition is reflected in this column. And in cell D8, the learning percentage is computed by the model. Okay. You can also look at the cumulative multiplier that is computed and which is used in obtaining the cumulative time across repetitions. So by changing the first time unit and also the learning percent, the table computer. This model will compute the cumulative time. Inventory management, there are a number of models that we have in the textbook, and we also have various interactive models that can be used. So, for example, the ABC inventory classification model. You can input the information here, and the Pareto chart will be updated accordingly. So are there any questions? Ganesh would like to pitch in terms of how you use this workbook in your classes?
Well, this is fantastic. I really like it. This is awesome. Can you maybe do one more on your inventory management, maybe one model, maybe, and then
Okay,
show how the, everything changes dynamically so that I can understand uh, how those P models or Q model,
oh,
whichever works.
sure. I think let's take a look at the fixed quantity models, because these models have graphs that accompany each model. So let's just take a look at the basic EOQ model and the cycle graph. So the basic parameters, or the basic input for the basic EOQ model, as reflected here, the annual demand, ordering cost, holding cost per unit per year, cost per unit. So by changing these numbers, let's say that the annual demand is, instead of 2,500, it is 4,000 units. Note how the optimum order quantity is computed, as well as the average inventory. Anytime any of the parameters of the problem are changed. And you will also note that the graph, the cycle, is computed, and the days per cycle is about 30 days, assuming a 365-day year that it shows here. It provides a graphical representation of the order cycle, 30-day period, and then you have the blue line here representing the rate of reduction in inventory over time. So you can also input the information, or you can use the scroll bar along each input parameter to see the effect on the cycle, the order cycle, whenever an assumption is changed. So this one is the economic order quantity, or models with what we might call sometimes as instantaneous replenishment. There are times when we do inventory for items that are built up over time. So we're dealing with economic production quantity, and here's what it looks like. So let me make this a little bit smaller so you can see the full graph that accompanies these model.
Yeah, this one, Rene, this is awesome because I think the students can pretty much do like a what if analysis, correct?
Right. Right. A good thing about having both visuals, graphs that accompany model that accompany a model is that these concepts are not abstract. So when we talk about increasing, what is the effect of, for example, increasing the setup cost. How does that affect the number of setups per year? Or how does that affect the level of the batch size? So those kinds of questions that can be answered by manipulating the information in these input parameters. So I would say, if we increase the setup cost from $127 to say, make it really expensive, how does that affect the batch size? So that can be, by manipulating, doing a what-if analysis, students will be able to see the relationship between parameters of a model and in this example, the batch size. So this is something that I use in my extensively in my strategic operations management class in the MBA program, where we focus on the concept and the application, and not do as much computation, the manual computation aspect, which is really more time consuming and not as efficient in terms of explaining the model in application.
This is wonderful. Now, have you tried the students working collaboratively, or do the students work independently or individually?
Well, for the most part, they work independently, right. But I put them in sort of self-help groups, or at least like study groups, and then they can use this independently, and then compare and talk about their solutions.
Great, that's pretty cool.
Yeah. So also extensive models here in the quality control. We have the Six Sigma model, and talking about maybe the capability indexes. And once again, this will show the control charts, as well as a graphing of the both the process spec and the data.
Sure.
There's another cool data or model we have in linear programming. So this is a two variable LP model, where
and this can be used for capacity planning, those kind of
correct.
things, correct?
Correct, right. So when you change the parameters or the coefficients, for example, let's change this to 1. Let's see how the graphing changes. And then, of course, once the coefficients and the assumptions of the model are entered into this model, we can run the solver to generate, let's see, it's running. And there you go. So the constraints, and then the decision variables, the objective, they are preset within the solver parameters dialog box. All we have to do is just click solve, and solver will generate the optimum solution. And in this case, the optimum solution is found at this corner point. So this one is for a two variable model. We also have a model for more than two variables. This is an example of maybe a transportation problem that can be applied
Right.
here, right?
Right. Applied to our logistics and transportation.
Correct, correct. And we have these additional models are not necessarily part of the textbook, but in case you want to cover this in your class, we can look at this location planning model, the center of gravity method, where you can determine the location of a warehouse, for example, or a plant that supplies to various points and see how the effect of by changing the volume demanded by for each destination point, you'll see that the center of gravity also changes. And for those of you
That's
who are, yeah, go ahead, Ganesh.
Yeah, that is a pretty cool thing to do because you can simply slide it
Mhm.
and then see how it dynamically changes. So that is a great learning thing for a student.
Correct.
Absolutely.
Yeah. And then for those of you who are using statistics as part of your lecture, we have here tables that convert z-scores into probabilities. So there are three of them. Z-scores in the negative, so the left side of the curve, or half curve. So we try to make these models as easy to use as much as possible.
Great. Awesome. Thank you so much, Rene. This is fantastic. I love this simulation and I've been using it in my class. The students love it. So it's been a wonderful thing. Absolutely.
Great,
Absolutely.
thanks. Yep.
And one of the things that I have found useful is after doing these simulations, I asked them to do a case study, and
Mhm.
that pretty much takes the theory on their mind and put the practicality out of it.
Mhm.
And at the end of the chapter, for each one of our chapters in our book, we have these extended case studies that pretty much encloses all the things that the students have learned in that chapter together. And this is a great thing to do as a team. I usually divide them into small teams and ask them to work on these case studies after doing these simulations. And I found that extremely, students are pretty happy with that. I mean, to learn how to learn and how to, get that. And I see my assessments also, learning assessments, the quizzes have also gone up pretty much.
Mhm.
The outcomes have gone better, enhanced, and things like that. So
Mhm.
thank you so much, Rene. Appreciate it. Just wanted to continue on one more thing. I would like to now share my screen.
Okay, let me stop sharing.
Sure. So basically, this textbook is written in such a way to help students understand how to learn operations and how to learn supply chain management using these simulations and case studies. So Rene actually has gone through this entire simulation, and he has told us how to do this, how to work with the students, and I find it extremely useful, and so do my students. And
Mhm.
some of the things that the simulations can do is to effectively learn. And this effective learning is an important part of our curriculum and our Roosevelt universities and other universities' objectives as well. So the best part of this whole thing is to encourage the collaboration and teamwork. And that basically is a project-based learning or experiential-based learning that helps our students to really enhance their ability not only to learn but also to communicate their analytical insights very effectively. So the case studies at the end of the chapter is great if you want to synthesize the contents of the chapter material. So it is not focused on one aspect of the chapter material, but basically synthesizes the entire chapter. So you can connect theory to practice and show how the concepts actually apply in real life situations so that the students can help themselves to strengthen their critical thinking through multiple perspectives and evaluation of these real world applications. The way people do case studies in different ways, and I find it useful to do this way, but I'm sure many of you who are listening to this webinar are much better teachers than me, and you know much better. The way that I do that is a very simple way of preparing the case study really well before the class. And then during the class, I do a little bit of a connectivity between the theory that I do in simulation and what the practical aspect of this case study is. And then I'll ask the students to do the case study in teams or individually if you want, and then encourage them to propose solutions and discuss the broader implications of the case. After that, I ask them to reflect and conclude by asking them what are the key takeaways from the discussion, highlighting both theoretical and practical aspects. In fact, I find it sometimes useful to ask them to even debate on a particular topic and say, okay, now these are the things to debate and what are the pros and cons, and you guys tell me what to do. So this this whole thing in the class, as well as some post-class assignments in terms of quizzes or in terms of homework, whichever way we want to do it, has helped the students to learn effectively, and their learning outcomes, has enhanced quite a bit throughout my career of teaching operations management. The other features of this book is basically on Industry 4.0 and data analytics. And all of you know this, Industry 4.0 is the future. And I would like to see how you as a teacher are using it in the industry uh, to see how industries do these Industry 4.0 enhancements and transformations, and how this can be learned in the class for your students. And this has given some kind of a appetite for the students to learn a little more on the practical side as well. As Rene pointed out, we wanted to include the optimization in terms of capacity management problems and logistics problems. And the simulation does a fantastic job of telling the students, hey, this is what happens. This is what happens if you do this. This is what happens if you change this parameter. This is what happens if you add this variable, those kind of things. And that is a pretty interesting part to the student to really understand, enhances their critical thinking and their decision-making capabilities as well. So without much ado, I would like to open for questions and answers. Thank you so much.
Might I also add one thing, one feature that the textbook has? We have a number of guided examples or video recorded examples on how to solve select problems from the textbook using the some of the models in the workbook. And the students, my students, like that, really, that feature that shows them the step-by-step process for selecting the appropriate model and then entering the information and then interpreting the results.
Cool, very cool.
I do have a question here. What type of instructor ancillary materials additionally come with the text?
So we have the usual ancillary materials, which includes the PowerPoint slides, apart from all Rene has shared as simulations and what he alluded as videos for certain models and things like that. It has got all the Excel in the Excel uh, solutions in Excel of all the problems, as well as all the book examples, so that you can pretty much tailor your course on whatever you want to. The book has got many models, many theoretical models, but if you want to choose and pick and choose accordingly to your time schedule and your schedule of your class, then you can pretty much do that. If you need anything else other than the usual things, please ask one of us, and we'll be happy to, put something to you, something for you also. No problems at all.
Awesome, thank you.
I think this is probably um, the only, well, I may be incorrect. The only textbook that has a supplement like the workbook of OSCM models that are highly interactive.
I think so too, Rene. But also the only textbook which has got data analytics probably included in it, as well as all the automation and including treatment of robotics and AI. That is pretty much that is the future of manufacturing. That is also put into the book, so the students can get a little more advanced thinking aloud of what is happening in this world right now. And in the next editions we follow, we'll expand on that a little more so that we can keep up with the currency of the situation in the industries, so that the students are well prepared for their careers.
So
All
do we have
right.
any other questions from our attendees?
I think that is all for questions. Well, thank you all for joining today, and thank you, Renee and Ganesh. As a reminder, this webinar is recorded and it will be sent to you in the coming days, and we'll provide you a link to the product page if you're interested in reviewing a copy. Thank you all and have a great rest of your day.
Well, thank you.
Thank you. Thank you very, very much.
Thank you.